My presentation, I titled it Internal Knowledge, because I'll be talking about what is truly theory to be on the inside of the Earth. Um, this comes from our whole lives. We've been taught that there's the Earth's crust, and there's a big ball of magma around the Earth, and there's a hot liquid core. But recently, new studies have been coming out showing that this is wrong and that it's actually cold. So some of the background from this, James Hutton, he's considered the father of modern geology, and he stated simply that granite is formed from a hot molten material. And because there were no other views or ideas to contest this theory, it was widely accepted, and it was just kind of rolled with. And since that point, people have been coming up with new ideas and other theories to reinforce it. An example of this is the plate tectonic theory, which is a whole premise based off of the tectonic plates of the Earth. They move and they kind of float on this mantle of lava. And this helps prove it because without that mantle, the tectonic plates would be a lot more complicated, whereas they wouldn't be able to get around and move as much. And I mean, even before James Hutton, people have believed that the Earth was filled with fire for a long time. Different civilizations, ancient civilizations such as ancient Rome and ancient, I don't know what it's called, but like the Hawaiians back in their ancient times, they believed that the Earth was full of fire, and this was because they had volcanoes in their society. I mean, one of the most famous ones is Pompeii, where this lava would come out of the ground. So it was only logical for them to believe that where does this lava come from? There must be more of it underneath our surface. So the primary and general cons against or supporting the idea that the Earth has a hot core is that the flow of the liquidized iron core is what creates the magnetic field, because you have the outer core spinning in a westward direction of liquidized iron and the inner core of liquidized nickel and iron spinning in the eastern direction. And these different rotating materials causes an electric charge which generates the electromagnetic field the Earth has today. Another one is as we drill down, the Earth gets hotter. Simply stated, everyone kind of knows that one. I feel we're all kind of familiar. And volcanoes show the release of some of the magma core after it's been built up from too much pressure. Again, all of us have heard this. People have been believing this for a very long time. Reasons why the Earth has a magma core. I have a little video here.
Drag and drop.
You know what, man.
It's perfect. Hi, I'm Kozenbeck, and I use Wix. We can go
So hold on, I just need to see the timestamp I put on this. Okay. 28.
The moon, but the deepest we have ever been on our own planet, is 2.4 miles into the crust at the Tautona mine in South Africa. What's down there? How does it affect us? New research has some insight. Scientists throughout history have mapped the inside of our planet by measuring the movement of seismic waves generated by earthquakes. Like sound waves, these are reflected and refracted, and they change speed as they pass through rocks of different densities and flows. Geologists believe as the primordial Earth cooled, heavy elements sank to the middle, and lighter elements floated to the top. The result was a multi-layer planet. The crust is the top 25-ish miles, then a 1,800-mile thick inner and outer mantle made of highly pressurized, superheated rock, which flows really slowly, like asphalt on a hot day. Under that is an inner and outer core made of heavy metals. This is where we think our magnetic field comes from. The outer core is a hot liquid iron alloy, and the inner core is probably solid nickel and iron.
So from that, we can just kind of see the farthest we've ever drilled down isn't super far, and this kind of just helps show kind of what modern science believes so far about the Earth's. He even states within that video that it is a theory and that nothing can be proven. So part of the pros on why the Earth has a cold core is one of the big ones is that water has been found in quartz or crystalline structures. I have objects to pass around that we can show. So there's a bubble in this quartz And in this one too, if you shake this one, you can actually hear it, or hold a light to the back of it, you can see the bubble within it. And it's just, for the longest time, people have been saying that quartz, it is created by heat and pressure, millions of years of heat and pressure. When, how can that happen if water is held within a quartz crystal? It's just illogical and unreasonable. Another one is the properties of a magnet. Everyone, or I don't know if everyone knows, but a magnet, when it is exposed to heat or exposed to a prolonging of heat, the magnetic effect of it begins to recede and eventually just goes away. So if the whole magnetic field of the Earth is being generated within a place where some people claim it's hotter than the sun, it just doesn't seem logical, and it just doesn't really work. Another one is the piezoelectric effect of quartz. I had a video for this for the next slide, but then I figured it would be better to show it. And so basically what the piezoelectric effect is quartz has this. It's basically when quartz is applied with pressure and kind of friction, an electric charge is given off. I don't know if it's dark enough, but you can kind of see it right there. Can people? Yeah. And some might say, that sparks. But if it was sparks, you'd see the pieces flying off past, and you would have remnants of remnants of the material that is being released off of the substance somewhere. And it would also contain a smell because of the burning substance that occurs. However, the piezoelectric effect also is removed when heat is applied. Again, discrediting the fact that quartz is made from heat, and heat is within the Earth. Again, a big claim to why heat can't exist is heat is the release of energy, and without that release of energy, or without a reaction, heat cannot exist. So one of the biggest questions being asked is, what if the Earth has all this heat stored in it? What is the primary reaction cause generating all this heat and liquefying all the rock within? There is no explanation that has come out yet, and I don't really see a logical one coming out anytime soon. Again, lava, where does this come from, if not explained by a giant magma pit in the Earth? What people don't really understand with volcanoes is before a volcano occurs, a bunch of micro earthquakes occur underneath the volcano, which help build the pressure. But along with these micro earthquakes, friction is generated, and this friction begins to melt the rock, and that's where we get our lava from. And again, with the drilling, drilling produces friction as well, so I don't know why that one was a big pro for it in the first place. And then, so this was the video about the piezoelectric effect. It just kind of demonstrates what I just did, so I feel like we don't really need to watch that. My opinion is that the Earth has a cold core, because why would our Earth be a lot different from the other planets floating out in the solar system? Like, we say Mars and the Moon and a bunch of these other solid planets are just cold rocks floating around. So, I mean, ours, it just kind of seems a little illogical that ours could be any different, other than the fact that we have the perfect positioning from the sun to be able to, for it to be habitable. But I also think further research needs to be done, and further research needs to be done, and we just need to be educating people, and the scientific community needs to be open, and which they always are, because science is changing every day. And yeah, this is my works cited page.
Question,
Oh, John.
Has the piezoelectrical effect, or whatever it's called, been used as a sustainable source of energy?
I don't necessarily think so. I didn't really research it being a source of energy. I was just kind of researching its effects and how it can apply to my topic. I do know that it can be used as a conductor, because if you apply an extreme amount of charge to the quartz structure, it can retain some of it and pass some of it on. So I'm not really sure on that. Yes.
Since we've only been able to like drill down so far, like kind of limited, what other research do you think could be done so we can know more?
So we can. Well, I mean, as far as I'm concerned, a lot of our knowledge or what we are going to guess about the Earth is mainly going to be theoretical until we can get further. Again, the testing of the seismic waves, it can be reliable. It's just the fact that if a seismic wave is going through the Earth, the different phases of matter, such as solid, liquid, gas, changes the way a wave moves. And these people that have been measuring these waves, they're not taking into account like it moving through the ocean, or we don't know how deep it's been going, or exactly like there's just a lot of unsureties within the argument on both sides. It's just that the cold core seems more reasonable and logical to me. Right.
I was just wondering about like volcanoes and like if it's a cold core, then like can you explain more on that?
Yeah, so a volcano primarily happens because the Earth does move. We all know this. The Earth, I mean, mountains grow, everything's kind of moving. Earthquakes happen, but why a volcano happens is because you have these micro earthquakes that come in large clusters. They create the friction which causes the Earth to kind of liquefy. And with the liquidity of the Earth, it kind of creates the pressure and it just builds and builds pressure while these micro earthquakes keep happening because they come in big clusters. And then it just gets to the point of where the last earthquake kind of makes it crack and then it all just kind of moves. Or that's to my knowledge. Again, I'd have to do more research on it.
Thank you, Carson.